Greetings, math people. So in the previous video we showed you how we got our trig sum difference identities. So hopefully you have all those identities. And now we're going to show you how we use those identities to find trigonometric values. What these identities do is they open up more angles that we can find the trig values from without the use of a calculator. So without these identities, we of course can do angles of 30, 45, and 60, and angles that have reference angles of 30, 45, and 60. And we also can do the 4 quadrantal angles, or any angle whose reference angle is one of the 4 quadrantal angles. So, you know, what we know now, what we know before the identities, we can do angles like 120, 210, 315, etc. With these identities, we can now do angles like 15, or 75, or 255, or 195. So they allow us to do a lot more angles. So let me show you an example. So let's say we wanted to find, and today I'll just deal with angles in degrees. Let's say we wanted to find the sine of 75 degrees. So I want to find the sine of 75 degrees. So when I see an angle like this, I try to think of a sum or a difference, and in many cases you can think of a sum or a difference, a sum and a difference that can do it. Just choose the one you want. So when I think of 75, I can think of the sine of 30 plus the sine of 45. And that's just one example. You could also think of the sine of 225 minus the sine of 150. And so forth and so on. I can think of an infinite number of angles whose sum or difference would equal 75. So, you know, you can choose whatever angles work. It's probably most beneficial if you can choose 2 angles that are in the first quadrant. That's probably going to be the best case to use because, you know, sine and cosine in quadrant 1 are both positive. When you go out of quadrant 1, you know, sometimes it will be negative. So, of course, it's easier to stay in quadrant 1 if you can. Of course, you won't always be able to. But for this particular problem, I can stay in quadrant 1 by using 30 and 45. So that's what I'm going to do. So I'm going to find the sine of 75 using 30 and 45 because I know the sine of 30 and 45 and I know the cosine of 30 and 45. So to do these identities, we have to know the sine and the cosine of these angles. And of course, the angles we're going to be using are going to be 30, 45, or 60, or angles that have reference angles of 30, 45, or 60, or the quadrantal angles. So based off the formula, so the sine of 75 is equal to the sine of 30 plus 45, which equals, so remember your formula, so this is the sine of u plus v. And remember that's the sine of u times the cosine of v plus the cosine of u times the sine of v. So in this case, it'll be the sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. And from there, all we're going to do is plug in the numbers of these trig values and just simplify. So the sine of 30 is 1/2. The cosine of 45 is the square root of 2 over 2. The cosine of 30 is the square root of 3 over 2. And the sine of 45 is the square root of 2 over 2. So if we multiply on this side, we'll get the square root of 2 over 4. So here we'll get the square root of 2 over 4. And on this side, we'll get the square root of 6 over 4. So our answer is the square root of 2 plus the square root of 6 over 4. And that's the answer. And for all of these problems, the sine and the cosine problems, answers will always look something like this. The difference will be sometimes there might be a plus or a minus, but they'll pretty much look in this form. Let's look at another example. So let's say we want to find the cosine. Let's say we want to find the cosine of 285. All right, I want to find the cosine of 285 degrees. Again, there's a myriad of angles that I can use whose sum and angles whose difference equals 285. Now, I can't use two angles that are in quadrant 1. There's no such two angles in quadrant 1 that would have a sum this big. So it's not going to be that case. But you want to use angles that you perceive to be the easiest to deal with, but they all may seem similar. So I'm just going to use the first two angles that come to mind. And since I did a sum on the previous example, I'm going to do a difference on this example, even though this is cosine and not sine, and it's slightly different. But I'm going to think of 285 as 315 minus 30. I also could have did, 225 plus 60, or 135 and 150. You get the picture. But I'm going to use 315 minus 30. So what I'm doing is a cosine difference identity. So again, so this is cosine of u minus v. And again, cosine of u minus v is cosine u times cosine v plus sine u times sine v. So this will be cosine 315 times cosine 30 plus sine 315 times sine 30. And again, we'll just plug in the values and simplify. And because we have this angle 315 that's not in quadrant 1, we're going to be very careful about the sign, positive, negative, of the numbers we get from 315. Alright, so the cosine of 315. So 315 has a reference angle of 45. And 315 is in quadrant 4. Cosine is positive in quadrant 4. And the cosine of 45 is the square root of 2 over 2. So therefore the cosine of 315 is positive square root of 2 over 2. Now cosine of 30 is the square root of 3 over 2. It's in quadrant 1, so of course it's going to be positive. Plus. Now the sine of 315, again 315 has a reference angle 45, sine of 45 is the square root of 2 over 2. 315 is in quadrant 4, sine is negative in quadrant 4. So the sine of 315 is the negative square root of 2 over 2. Negative square root of 2 over 2. And the sine of 30, of course, is 1/2. Sine of 30, 1/2, of course, is positive. 30 is in quadrant 1. So when we multiply these, we'll get the square root of 6 over 4. Square root of 6 over 4 minus the square root of 2 over 4. So the square root of 6 minus the square root of 2 over 4. Again, the sine and cosine answers are typically going to take the look you see here, with only changes being plus or minuses in different spots. Okay, let's look at a tangent example. Lastly, so let's say we take the tangent, of 195. we're going to look at the tangent of 195. And I do want to make a point about tangents. So let me look at a couple of options I can use here. So for the tangent of 195, I could use the tangent of 135 plus 60. Right? Tangent of 195 plus 60. I could also, and I'm going to make a point about this, I could also use the tangent of 225 minus 30. Now, for tangent, whenever possible, you would prefer to use an angle that has a reference angle of 60 versus an angle that has a reference angle of 30. So if I had these two options, to me the easiest option is this guy, because this one deals with an angle of 60 and this one deals with an angle of 30. They'll both give you the same answer, of course. To deal with 30, the tangent of 30 is the square root of 3 over 3. So these tangent problems, there's a little part at the end where you have to do some simplifying. It's easier to simplify that ending part if you're just dealing with the square root of 3. The tangent of 60 is just the square root of 3 versus dealing with the square root of 3 over 3. Still can be done, you know, it's not impossible, but it's easier to deal with an angle that has 60 versus an angle that has 30. So whenever possible when doing a tangent sum difference, try to find an angle that has a reference angle of 60 instead of an angle that has a reference angle of 30. Okay, so the easy example for me is to use 135 and 60. So this will be the tangent of 135 plus the tangent of 60 over 1 minus the tangent of 135 times the tangent of 60. And so that's the tangent sum identity. So now once again we're just going to plug in the numbers and simplify. Now again on these tangent problems, the simplifying process is a little more intense. It's not crazy, it's not bananas, but it's just a little more intense. So let's see, so 135 has a reference angle of 45, tangent of 45 is 1. 135 is in quadrant 2 and tangent is negative in quadrant 2. So the tangent of 135 is negative 1. So this is negative 1 plus the tangent of 60 is the square root of 3 over 1 minus. Now again, this will be negative 1 times the square root of 3. So that's the negative square root of 3. So this minus sign will turn to a plus. So plus the square root of 3. So we typically, at least on the pre-calculus level, we typically don't leave the answer like this. When you get a little higher in mathematics, you get a little more lazier, so in higher levels of mathematics, you would just leave it like this. But typically for pre-cal, there's a lot of more stipulations and technicalities and things. So typically we simplify this guy. And so what we do is we try to rationalize this denominator here. And so to rationalize this denominator, we kind of use the difference of squares approach. So you may be familiar with this in algebra, that a plus b times a minus b equals a squared minus b squared, of course. So if I apply this principle to this, what's going to happen is these two guys are going to end up being squared and subtracted. And if these two guys are going to end up being squared, there's no longer going to be a radical on the bottom. So I have rationalized my denominator. So to pull this off on these type of problems, you look at your denominator, and of course whatever I multiply, I have to multiply by the top and the bottom, but I'm going to multiply by the conjugate of this denominator, meaning whatever sign is here, I'm going to use the opposite sign. If it's a plus, I'm going to turn it to a minus and multiply. If it's a minus, I'm going to turn it to a plus and multiply top and bottom. So what I'm going to do is multiply the top and bottom by 1 minus the square root of 3. So 1 minus the square root of 3, 1 minus the square root of 3. Again, I'm multiplying the top and the bottom because this is really 1, so I'm not changing the value of anything. And again, my objective of doing so is to rationalize this denominator. So when I multiply, the denominator is always easy because again, it's just a squared minus b squared. So it's going to be 1 minus 3. You just square these two numbers and subtract them. So this is just 1 minus 3. 1 minus 3 is negative 2. Denominator is done. The top, there's going to be a little bit of work on the top. So the top, you really have to go through and kind of multiply. So negative 1 times 1 is negative 1. And here you have a positive square root of 3, right? And here you have another positive square root of 3. So you have a square root of 3 and another square root of 3. So that's 2 times the square root of 3. And then here you have the square root of 3 times the negative square root of 3, which is negative 3. So the square root of 3 times the negative square root of 3 is negative 3. So minus 3. And we can combine these two numbers here. Negative 1 and negative 3 is negative 4. So you have negative 4 plus 2 times the square root of 3 divided by negative 2. And you can just divide top and bottom by negative 2. And this will be positive 2 minus the square root of 3. And your trig sum difference answers will all kind of look like this. Again, only difference being signs will change depending on the angle. So that's how you do your trig sum difference problems. I did an example of sine, cosine, and tangent. So this should be enough information for you to do problems like this.